Hello, everyone, and welcome to the GeekNarrator podcast. As usual, I'm your host, Kaival Yapte, and today we are going to talk about data platforms and how to build them, how to make them robust. I am joined by Francesco, and who works at a company called Ivan, and he has some good experience with building data platforms, and he has some insightful tips to share with us today. So, without further delay, welcome, Francesco, and let's start with a bit of introduction about your background, about what you're doing at Ivan, and also about your, interest into data platform.
Well, thanks for having me. It's a pleasure being here, guest of this podcast, or how do you call it? It's a
Yeah,
podcast.
yeah,
Like we are recording a video. It's a mix of things, but
yeah.
I'm glad to be here. What I do, I'm a senior developer advocate at Ivan, which is an amazing company taking the best of the open source and trying to make it more developer friendly. Let's say that, for example, you are a developer. You have a perfect mission to build some sort of service for your users. You don't really want to spend half of your time trying to set up a Postgres database, and even more trying to, for example, set up SSL, check that the backups are correct, and you can maybe restore them, or check that how your logs are doing, how your metrics are doing. What we do at Ivan is basically solve this problem for you. So you can come to Ivan and you can say, I want a couple of Postgres. Maybe I want to join that with some Kafka, and maybe I want a little bit of OpenSearch. All the technologies are the pure open source technologies. So it's your choice to choose to work with Ivan. It's your choice also to take your Kafka data and move it somewhere else. But what we offer is an amazing service, which is always there. It's 99.99% SLA, so it's trustable. We do our backups. We ensure that all the services are secured. We give dedicated virtual machines so you don't have noisy neighbors. This is basically to give a service which is optimal, but always based on the good open source tools that we all love. And another important bit about Ivan is that we are not only, let's say, using open source to make our business. We are trying to give as much back as possible. So we try to build tools. For example, we have a backup tool for Postgres and MySQL that we use for our needs. But since it's a backup tool for Postgres on top of cloud storage, we thought that we could open source it. So we try to give as much as possible back to the community itself, because we believe that together we will grow better. So that's why it's a good opportunity for developers, because you don't have to care about all the setup. At the same thing, it's a good company that tries to push all the world forward at the same time.
Okay, yeah, very interesting. I mean, some interesting points there. As a developer, I want to do minimal when it comes to setup, and I want to just write code, and that's my primary focus. So if anything that helps me there, I don't have to build stuff. I can just use stuff, ready-made stuff. I think that's really useful. So thanks for the introduction. So cool. I'm excited to discuss all about data platforms today. As usual, I don't want to assume that everyone of our viewers know what are data platforms. So let's start with very basic. What are data platforms? What is included in them and what is not included?
That's a good question. And I don't know if there is a definition of a data platform. I believe it's anything that can host data. It can be a bucket. Like
Yeah.
if you put papers in a bucket, that is some sort of data platform which hosts data. Can be a database, can be an S3 bucket itself, can be a data technology that allows you to transform the data. Is anything that in some way or another touches data, stores the data, allows you to transform. And in the current times, we see in almost all the companies that data platform is not only tied to one specific vendor or specific technology. Data platform nowadays, it's a set of tools. And in my opinion, if you want to create a data platform, something where let's start from a step back. Data is, at this point of time, the most valuable asset for companies. Making sure that whatever you do with your data, whatever decision you make about your data, where you store it, how you transform it, is something that will support your organization over the years, is something really crucial.
Yeah.
Because your company growth is, at this point of time, strictly related to your data growth or your data being always available. So our data platform is something that is supporting the companies into storing and accessing and creating insights about their most strategic asset, which is data.
Yeah, that's an interesting point. In modern systems, everything has a lot of data and different types of data. Is it only about data at rest or also data in motion?
It's all about data. The distinction between rest and motion, I would say, depends on use case. If you think about, let's say, orders, website orders.
Yeah.
The same data set is in motion when you are checking the clickstream, for example, and you want to maybe customize the experience for the user based on the behavior. Is at rest if you have to query the clickstream or the orders of the previous month. So the data platform, in this case, should support all the use cases.
Okay.
And shouldn't stop you from analyzing, changing, modifying the data, understanding which data assets you have just because it's in one technology or in the other, or one part of the process or in the other.
Yeah, that makes sense. So basically, it's all about data, whether it be real time data or historical data or everything around data, whether it be at rest or at motion, and the systems that support it, that makes it easy for you to access that data in a depending on the use case. I think that itself is included in the data platform. So talking about the modern data platform system, like what are the use cases typically companies use for having the data platforms?
Well, this is a question which is wide as the word.
Yeah.
Because literally every company has some sort of data.
Yeah.
If I go to the little shop next door, which is fixing the shoes, the person will have some sort of notebook where he is writing, I need to fix these shoes by next week. This is data.
Yeah.
So this is the beauty, I believe, of the data land. I've been living in the data land since 15 years, the entire my career.
Yeah.
The beauty of the data land is that everybody has data. And the other beauty is that you can showcase technologies using examples that, even if are not 100% accurate to your use case, you will be able to relate to something that talks to you.
Yeah.
I give you an example. When I started with Ivan, my initial goal was to try to make the Kafka experience, Kafka is a streaming technology, the Kafka experience a little bit less complex for new people approaching Kafka. One of the complexities about a streaming technology is that it's very hard to find a streaming source dataset, because you find a lot of REST dataset, a lot of fixed dataset, like last year orders for a particular website or something like that.
Yeah.
Having a continuous flow of information is a little bit more complex. What I did there, I created in Python a fake pizza order generator. Now, I don't think we have any pizza chains within our customers. I don't think there are a lot of online or new business about pizza chains going out. Still, the simplicity of the order, the fact that it's a streaming dataset, the type of transformation that you can do on top of that dataset, the fact that if you receive a pizza order, you will have someone reading that pizza order, which will make the pizza, someone else doing the inventory, someone else doing the billing. Well, if you remove pizza from the equation, this is the same as an e-commerce website. So that's the beauty of data, is that there is a ton of different use cases, but there is something in common which allows you to create examples that are not exactly what you do, but you can easily relate to and take it home, the part that is interesting to you.
Yeah, that makes sense. And as they say, data is at the center of any business today. So, and there's a lot of data. So you need some platforms to, process and access that data in a effective manner. And it's funny that you also took an example of a pizza service, a pizza order, because I did a podcast on geo-distributed application and we built a pizza service. So yeah, pizza is love, is what I see.
Yeah.
Awesome. Talking about data platforms a little bit more, we say that data platforms need to be robust, right? So what do we mean by robust data platforms?
I believe when you choose a data platform is a long-term decision. We see, like, at least in my experience, I saw a lot of, for example, changes in the front end of applications.
Yeah.
Where, you implement the new framework, you have the new capabilities and stuff like that. But I see very, very rare changes in the backend of a data solution.
Yeah.
This is because changing the backend, I believe it's quite complex and error prone. Even more, when you already offer a service, you don't like the thing that you want is stability on the performance on retrieval data, the retrieval of the data or pushing the data. If you change the mechanism that handles the data, you will possibly encounter some problems. And this is the unexpected bit, which is not what people want. So despite the fact that, there are some companies that tells that you can move from technology A easily to technology B or to technology C, that is never 100% true.
Yeah.
That it's true maybe if you want to move from Postgres vendor A to vendor B, staying in the same technology, but when you swap the technology, the capability of having one-to-one matching across all the features that you're using, it's very rare.
Absolutely.
So this means that what you choose as a data technology, data solution now will stay with you for years. So choosing something which is robust, what I mean with robust is that allows you and your business to grow. It doesn't limit your business because there is a limit on the data storage, data platform solution.
Yeah.
A robust solution, a robust data solution is something that doesn't provide you almost any limit to the growth of your business.
Okay. Yeah.
And also, another important thing, going back to what we said initially about Ivan, but it's not limited to Ivan, is something that doesn't burn you a lot of time. because the more robust, the more self-sufficient is the data platform, the less you have to dedicate time to it in order to make it work.
Yeah, absolutely. So with any data platform, you want to focus on the real problem that you wanted to solve and not the problems that the data platform itself is creating for you. So the less problems the data platform itself has, the more you can focus on your business problem, and that's what we want. And I think you mentioned some of the point that you need your data platform to be fast. You need it to be, scale for your future needs, because, once you're stuck with a data platform or the tools that you're using, it's for years. It's for many years. You cannot change it too often. And you also touched upon like performance and I guess reliability, because you don't want any problems. So what are some dimensions to look at, data platforms to ensure that they are robust? Like what are the dimensions we are talking about here?
So to make things simple, there is an acronym. So the acronym is SOFT. SOFT stands for scalable, observable, fast, and trustworthy. And these are four main dimensions, which then, like a tree, they create other mini dimension, other mini dimension. So I believe it's good to start within each of the four pillars and try to go down deep into each one of them.
Yeah.
Let's start with the scalability.
Yeah.
And because it's, if you're lucky with your business, scalability is something that you will have to care about.
Yeah.
Because if you're lucky, today you have 10 orders per day, tomorrow you have 10,000 orders per day.
Yeah.
Then 1 million. So you need to have a platform that can technologically scale with your demand. And again, this deserves another episode probably, but how you scale technologically, you have many directions, because you can scale it vertically, you can scale by making bigger nodes. You can scale horizontally if you can, for example, have a distributed architecture where you can have 5 nodes storing your data, or 6 nodes or 9 nodes. But then for data platform, for stuff that has to store data, and also for resiliency, you may think about, okay, do we have a data platform which offers primary replica setup, where I have only one node which will accept, for example, writes, and all the replicas will be able to accept only reads? Or are all the nodes equal? So understanding these little details about the chosen technologies or set of technologies will allow you to understand how much you can scale, what are the limits, and also understand how easy it is to scale.
Yeah.
So is it a click of a button? Do I need to, go and purchase 5 different new servers, and in 3 months I will be able to scale? Now, understanding, or at least evaluating all these options, should be done immediately, because you don't want to be stuck in 1 year, stop your business for 2 months, or like slow down the developments on your business needs because you need to take care about migration in technology.
Yeah.
And this is just about the technological scaling. But then I believe there are other types of scaling that needs to be thought about. One is about business case. Because if you choose a data solution, most of the time will not be used only for one specific purpose in your company. Yeah. You may host different data sets, different transformations, and you want to have enough options to secure each of the data sets, each of the use cases. This could be done because, I'm Italian, people will trust to give me only Italian data, and this could be a way of segmenting the data. Or it could be because I'm in sales, I shouldn't see any HR data.
Yeah.
So you need to have enough toggles to be able to segment all the use cases. And then, always regarding scaling, there is a very important factor, specifically because we said that data platform that you choose now will stay with you for years.
Yeah.
And it's about the human scaling. Because if you are working on a specific data platform, and let's say you have 2 developers, maybe tomorrow you will need 5. Maybe in 2 years you will need 10 because out of the 5 that you have now, 2 or 3 left. So understanding if the chosen technology, the chosen set of technologies has a strong community, a talent pool, which can allow you to not run out of people in 2 years, is something that you should care about. And lastly, about scaling, is about understanding if we can afford it. Because we could choose the perfect technology that gives you all you need, but then it costs you €1 per order, and you make only 20 cents per order. So you build a perfect castle, but now you cannot use it.
Yeah.
The door is locked. So understanding how much does it cost? How much does it cost if I need to create a bigger size? Or if there are steps in the increase of, in the technology scaling that will make my solution way, way more expensive.
Yeah.
Understanding this kind of different direction of scaling is something that we need, because we need to perform, because scaling is not only about technology. There are several different aspects in the game which can make a technology which can scale perfectly on the pure tech side not being affordable financially or without any support from humans.
Yeah, that makes sense. Just to validate, or let's say to summarize, because these are some of the very interesting points. So when we say scalability, as developers, we only think about how well it scales technologically, but there are other dimensions to it. And talking about the technological scalability, I think understanding the scaling model, like how certain technology scales with more data, more number of requests coming in, I think it helps a lot. And talking about the other part, which was about being compliant with, if you want your data to be within, confined within certain boundaries, how configurable that data system is. And also, as you mentioned, like salesperson or sales employee should not be able to access HR data or some other data. So I think it creates like a boundary of between data types of data systems as well. So these configurations, if they are not available, it might not be a right choice, depending on the use case, again, depending on your business. I think the third point you mentioned was about the availability of developers to work on that technology, because as you said, it's for the future. It's not going to go away pretty soon. It's not going to change. So you need a good community of developers, so you can hire more people, because that is another scaling part of it. And I think the fourth one was cost effectiveness, and which interests me the most, because as you mentioned, you can build like the most amazing castle, but if it's not cost effective, if you're losing money there, it's not going to be working for you. Talking about the cost, like how as a developer, let's say I am working at a startup, I am given the responsibility to evaluate different technologies for cost. How should I go about evaluating the cost right before I could actually use those technologies, specifically if these are vendors?
I believe for data platforms, what we see is kind of only 2 ways of more or less selling the data platform. Well, maybe 3, let's say. There is the old school of you pay a license,
Yeah.
and there you go. And then there is cloud, where you have either a per consumption, per call billing, or a fixed billing, a fixed monthly billing, depending on the size of your data platform or your services.
Yeah.
Now, this is where the tricky part is, because evaluating how many calls you will have can be a little bit tricky.
Yeah.
And let's say it's about, I take it personally as like when I decided which type of mortgage I wanted to do for my house. You have the fixed mortgage that costs you a little bit more for 20, but it's the same amount of money for 20 years. Or you have the variable mortgage, which at the beginning costs less, but then you don't know.
Yeah.
It's a matter of, doing your math, evaluating how much you can forecast your traffic, how much you can forecast the growth of your platform usage, and then basically deciding there. What we do at Ivan, for example, is you pay for the size of the instance. You can do as many calls you want. You can add as many options for within the ones that we provide you as much as you want. You pay for the size of the instance.
Yeah.
Other companies are having a different approach, which better fits the business model. And, it's up to you to do the math and understand if you want to be more like sure about what you will pay next month, or if you are okay into refactoring some of your profit, which probably comes with the with having a bigger number of API calls, back into the cost of the data platform.
Yeah. That's fair enough. I mean, as developers, we actually need to understand the type of workload and the scale that we are expecting. I mean, at least we should have some estimates and have some buffer to it and evaluate cost, and based on that, choose the right technology. That makes sense. Let's move on to the next part, which is, I think you mentioned observability.
Yes. Again, this is a bit where most of the time is not the first thing that you think about when you choose a data platform, because you want just to build. You look at the feature of the data platform, you look at the scalability, okay, but then you look at the feature, okay, do I have the function to extract the tokens from the text because I need that? Check. Do I have the machine learning function? Check. Okay, I go with this solution. However, I've been doing consultancy in the enterprise world for quite some time. And observability is something that doesn't bite you immediately. It bites you in the medium long term. Because having a platform which is observable means that you can understand what is happening.
Yeah.
First of all, you can understand what is happening now. So monitoring. You can understand if your database or your Kafka or your whatever is under stress, if you need to upgrade to a bigger cluster, or because it's the Black Friday, I know that the peak of traffic will stop in 2 hours and we still have 30% of CPU left. It's all good. But still, if you don't have the monitoring in place, you cannot do anything.
Yeah.
So having the ability to understand how is the situation now is absolutely key. But then observability is not only about that. Specifically, if you start with a use case, then you add another use case, then your company grows to 100 people, and then you have 15 use cases. Now you are a new person, maybe a data scientist that costs a fortune.
Yeah.
And you tell them, look, that I want to do a machine learning model to predict customer churn. should the data scientist spend 2 months to try to find what customer data you have in your company? Or should you be able to recreate the bird's eye view on all your data all your data assets, and basically handle to your data scientist, here are all the touch points where we have customer data.
Yeah.
This is very useful to recreate the bird's eye view because you empower people with no knowledge about the company to immediately start acting or start connecting to the right people.
Yeah.
You reduce the options about rebuilding again and again the same thing, because you don't know that team A already did a work about churning customers. You redo the same work again now. And then there is interesting points about, recreating data lineage, understanding security implication. Who can access my customer information across the 5 or 6 different data technologies that I have? And if you relate this, it's also GDPR. I want to know who can see my data and what a company does with my data. If you cannot recreate the bird's eye view across all the technologies that you're using, well, that is a little bit more complex. And then I believe always about observability is about the ability to version the data and replay if something goes wrong. Nobody's perfect.
Yeah.
Having the ability of, okay, we pushed this, we added a small bug, let's replay all the orders from yesterday to fix the bug.
Yeah.
Let's version the data and compare what you do in your new application with what is the expected outcome of the application of the version before. It's all about, being able to observe what is the expected behaviors and what is the new behavior. And maybe in one case, revert a change before it's too late.
Yeah. That makes sense. And, there are, as you mentioned, there are multiple dimensions to observability as well. So you want to know what is happening right now with your application. You want to know what has been happening, let's say, in the past 30 days or something. You also want to understand or have a big picture of what kind of data you have, where it exists. And you also want to be able to replay or have some sort of correction mechanism when things go bad. And I've been working in billing domain, and there is always a lot of prices and here and there, and a small bug would have a lot of impact on the bill that we create. And then we had to replay certain events from Kafka, let's say, between certain timestamp, and then there was always this thing happening. And if we don't have a mechanism to do that easily without creating more trouble, I think it's always a big problem. So yeah, and we also want to see if the correction actually happened and what was the behavior. As you said, you want to compare between before the bug and after the bug, what is happening, and take quick actions on top of that. So yes, I think observability should be at the center. Sounds good to me. And talking about the next point, which is I think you mentioned fast, which is kind of interrelated to having observability and then being able to act on top of it, right? So if your solution is not fast enough, you even querying itself takes a lot of time, then you might face some problems. So let's throw a little bit light on that idea.
Yeah, absolutely. It's everybody wants to go fast. We
Yeah.
don't have the time now to, for 3, 4, 5 years of my career, I was the person who the next morning was hoping for the ETL to be finished in order to check the data of the day before.
Yeah.
we don't have that luxury anymore, or at least for a lot of use cases, we cannot wait.
Yeah.
We need to act immediately. So one thing that I wanted to say, not all use cases need to act fast.
Yeah.
If you need to do the end of the month billing, can take 5 hours during the night. It's perfectly fine. But on the other side, if we need to customize the experience on a website based on the history of clicks, we need to have that information kind of in near real time. So fast, it's about the performance of the platform, and it's about what is expected.
Yeah.
But then that's only one bit of being fast. It's also the amount of time, for example, that it takes to develop something in the platform. As I was mentioning before, if the platform offers the function to tokenize a text out of the box, well, it takes me 1 minute to create something to call the function, and it's done. If I don't have that luxury, well, bad luck. It takes me maybe 1 month to create a suboptimal solution that does something similar.
Yeah.
So when you think about time to develop, it's the features that the data platform offers, is the use case that you are approaching the data platform with, and also is the existing knowledge of the team. Because if you need to reskill an entire team on a completely different technology because of a feature, well, maybe that was the good feature that you were aiming for, but now you have 2 months of people not being able to progress as fast as they were doing before. And then it's time to deliver and execute. So if I build something, how much time does it take to push to production? How much time does it take to execute the workload? Is it in line with my expectations? Again, when you talk about time to delivery, do we have the options to relate to what we were saying before, to check if the result of a new deployment is correct or not? All these kind of things are adding to the pile of time to deliver and time to develop. And then lastly is the time that you really don't want to feel, because it's the time to recover.
Yeah.
It's the time that you will possibly be offline because something went bad. But it's absolutely key to estimate this. If a database goes down, do you have a replica somewhere else that within seconds can take the load?
Yeah.
Do you have a cluster of nodes, so even if 1 or 2 are missing, the cluster still remain functional, even if with a little bit worse performance? Or do you have to call a friend to drive to somewhere to give you an USB key with the 100 gigabytes of backup that you have stored from last month? The time to recover is something, and the options for failing over and stuff like that is all like stuff that we need to understand, because we want to be fast, not only when everything goes well, but also when something goes wrong.
Yeah. That again has so many dimensions to it. So fast does not only mean that, the execution of the operation that you're performing is fast, but also, you should be able to deliver fast, develop new features fast, recover fast, as you mentioned, and also scale fast, right? Like we talked about scalability, but then if scaling itself takes a lot of time, then again, so I think these points are some or the other way interconnected, that you also want to be want to have observability in your system, so you can observe that you need to scale or not, and then the scaling also needs to be fast. So in a way, scalability, observability, and fast kind of interconnected. So you cannot live without any one of these, right? And
Absolutely. It's like the directions of the soft framework, the soft methodology are four, but they are all interconnected. You touch about the scalability. The same about the time to develop is related to the amount of people that you have or that you can hire, the talent pool, the community. The one other thing that it's also interesting is maybe the time to do a specific thing now is 2 months because there is no feature. What about if there is the feature in the next release of the tool? Also, that goes back to the community part, or the vendor part. You need to find to select a vendor which you can trust, that it can support your needs in the future, or an open source project with a big enough community that you know it will not, for example, stop new development in 1 year, because again, at that point, you become stuck. Your data platform doesn't move with your new needs.
Yeah. This is true with any of the cloud providers or any vendors that we go for, right? Like they need to have some SLAs on answering our queries. They need to be supporting with us with new features. They need to have like clear roadmap and all that. And also, as you mentioned, the community part of it, like, you know, they should be educating more and more developers. So it's easy to hire. So we were just talking about, you know, interconnected, how interconnected all these dimensions are. And I think it makes a lot of sense. And one question that I had for the dimension fast is, so fast is very subjective, like fast for someone else might be slow for someone else. So how fast are we talking about here, and what kind of use cases? So fast. So this is the exact question I always have for real time. Like, what is real time? Some people are always fine with near real time. So when we say real time and fast, as a developer, how should I go for it?
Does exactly real time exist anyhow? By the
It's
time
always
that I
near real
click
time.
on a website, my click goes to the server. There is always a minimal latency.
Yeah.
So I believe, again, it's all about setting the expectations, setting the boundaries. For example, let's say that you come to a website. You spend 15 seconds or 20 seconds browsing on a page to, you know, because I'm selling to you shoes and you want to check all the shoes that I'm listing. I can do analytics.
Yeah.
So I can say that you spend on average between 20 and 30 seconds on that page. This means that I have 20 or 30 seconds to show you something. Maybe not 20 or 30, because if you want to see that, I have 10 seconds or 5 seconds to be able to do my processing before I show you something. Or maybe we are talking about milliseconds because, you know, it's a self-service driving car. And we are talking about microseconds or nanoseconds or milliseconds. Depending on the use case, this will drive how fast you need to react. There is never real time, because any time your data point does a jump, even minimal, this adds a delay.
Yeah. Absolutely. I mean, you can't get away with the physical latency of data traveling from one place to another. It's always near real time. And as you said, fast depends on the use case. Some, like for some applications, let's say, for example, a click stream or something like that, fast means really fast. And for something like ordering a pizza, fast is something different. So as you mentioned, it depends on the use case. Cool, sounds good. Let's move on to the next point, which is the trustability, or how do you say that?
Trustworthy. Yeah, it's
trustworthy.
Trustability.
Okay.
It's correct.
Yeah. Okay.
And again, this is not, but well, this is something that possibly will not bite you immediately. And I'm saying that because I'm coming the beginning of my career was to build what now is called what it was called business intelligence, which if you tell you now, that makes me sound like an old person, because now everything is analytics and machine learning and AI.
Yeah.
I started doing centralized business intelligence. So this means that huge companies couldn't cope with everybody having their own Excel files and running around with different versions of the data. They wanted to build data warehouses and expose all the metrics via beautiful dashboards in a standard manner to the entire company. So in huge companies, there was only one way to measure customer churn.
Yeah.
One way to measure how many people ordered yesterday. One way to measure how many sales we did in May 2020. Then, some years later, tools like Tableau came out. And people said, everything is self-service. So they went and they scratched all the enterprise BI system because they were too slow to progress. Now they have Tableau. Everybody could analyze their own data. Well, guess what? Yes, it's true. Everybody can analyze your own data, but the end result is the same situation as the people running with their Excel spreadsheet across the company and not having the same unified version of what is true data across the company.
Yeah.
So trustworthy, building a platform which is trustworthy means that the data is correct, that there is the unique version of the truth across the company. And this, again, ties back to recreating the bird eye view, avoiding duplicated effort. If there is only one way of calculating customer churn, we don't have to get another team building another way of doing that.
Yeah.
And then also it goes back to tying with security. Can I isolate all my, data? It's data silos, but it's not in a bad way saying data silos, because creating data silos or exposing only what is needed, what should be exposed, but still having the option to keep all the things near each other in case if a new use case is needed, but having the ability to properly secure the data is needed, because we live now with a lot of data regulations. And I'm happy for it. I'm happy for the GDPR. I'm happy for the ability to say, I want to know all the data that you have about me. And I want to be secure that you are not misusing my data.
Yeah.
But then security is something that you can build, but it's also something that comes with your technological choices.
Yeah.
Because you are choosing a vendor, an open source project, and the entire ecosystem. When you choose a vendor, are you sure that the vendor will be there in 3 years, in 5 years? That the vendor will be able to support you with the needed feature? Do you have a way of, requesting features? Or if it's an open source project, or if it's a managed solution across an open source project, what is the community of the project? The good part of being in the open is that if you have someone capable, if there is a feature that you absolutely need, well, there are possibly ways of implementing that.
Yeah.
If you are going with a vendor, if you're lucky, you have a good connection with the vendor and you can push for the feature to be added. The other interesting bit about the security is also regarding regulations and the option about where is the data. Which, for example, cloud can you use? Do you use cloud? Do you store it on a server in your backyard? Where is the backup of that server? Because maybe you don't want the backup to be in the same physical location as the server itself, because if that location takes fire, you don't have data anymore.
Yeah.
But also with the cloud, you may need to ensure that all the data of my pizza shop and of my customer needs to be stored and processed in Italy, because this is the regulation for pizza. We are pretty serious. So depending on those requirements, again, there is no one rule that applies to everybody. It's about what segment you are in, what are the requirements of that segment, and what are the technological choices and the vendor and the cloud option that you have across to where to deploy your services.
Yeah.
Yeah, and at the very end, as we touched before, you want to ensure that the data is correct. That is the basic thing. And the data is correct when, as we said, is consistent. There is one way to calculate churn. Is repeatable, linked back to what we were saying about the time to develop.
Yeah.
If I rerun the same job, does it reproduce the same data?
Yeah.
Is consistent. Consistent means that it's consistently accurate and is consistently delivered. Again, coming back to my times, the worst thing that you could do is, okay, we have this beautiful dashboard, which is ready for the CTO of the huge company, but only half of the days or 3 out of 4 days is inaccurate, or the results are available at 11 a.m. instead of 9 a.m.
Yeah.
This doesn't build trust in the system itself. And believe me, if you don't have a trustable system, people will take the raw data, download to Excel, and run across the company with this Excel spreadsheet again.
Yeah.
So this needs to be addressed. And basically, this is how you build trust.
Yeah.
You build trust a little bit by doing stuff yourself, and a little bit by checking when you make a choice.
Yeah, that makes sense. I've seen this happening. The point that you mentioned, that if they don't trust your system or your guarantees, they would just make a copy of your data and go and do their own processing. So that's like doing it in reverse. That every team would then have their own copy of data, their own set of technologies that they work with, data accessing it, and then you end up as an organization in these different distributed systems that have their own way of doing and accessing data, which is not cost effective, first of all, and it's all siloed, as you mentioned.
I have one thing here.
Yeah.
It's not related to trust. Sometimes, let's go back to the string tokenization problem that we were talking about before. Let's say that your data is in one platform, which offers a lot of features, but doesn't offer string tokenization. Okay. And you extremely need the string tokenization. Building a robust data platform means also enabling you to find a way to do string tokenization without losing 2 months.
Yeah.
If, in order to do string tokenization, I need to take the data from platform A to platform B, because that offers the tokenization item, I should be able to do that in one only way, which we can control and which is reliable, it's correct, is consistent. I would say the fact that different teams will want to, use different platforms to achieve their goals is something that we cannot stop.
Yeah.
But what we can do is, when we define robust data platform, is to ensure that the end-to-end delivery of the data is correct, is scalable, observable, trustable, and fast.
Yeah.
Because the data platform meaning is not just a data technology. It spans across several different technologies. It's about, again, it's about empowering the business to achieve the goals without posing technological limits.
Yeah, that makes sense. It's more about, working together, finding a good solution, having a clear roadmap, and not blocking you on certain features, helping you out if there are certain limitations to the platform. It's about creating that trust, so you will have that feature, let's say, in coming months, or we will help you to build that feature on your own, something like that, right?
Yes, like let's go back to the tokenization problem. Let's say that, clear example, you have your data in a relational database that doesn't offer tokenization, but you have OpenSearch that offers tokenization. People and the team that wants to do tokenization, they have the knowledge of OpenSearch. If you force them to work with your relational database, what they will do is exactly what we said before. They will export the data, import in OpenSearch without telling you, and do it in OpenSearch. Yeah. This is very risky because it's one-off, or maybe not one-off, but once per day. Where does the export resides? Yeah. Who is like in charge of the export? What you can offer, for example, is let me take care of it. I put Kafka in the middle. You don't need to take care of the export. Kafka scales. Kafka can talk with the relational database. Kafka can talk with OpenSearch. We build a data solution. You are happy to use your own tool. I'm happy because I have my complete data lineage with Kafka, and I know what's happening. Yeah. Again, it's about understanding the needs and not forcing people into doing something that they don't want, because they will find other alternatives. Is to build a data platform that is robust and can support all the use cases.
Makes sense. If I use Ivan, do I have to care about soft at all, or Ivan will take care of soft for me?
Okay, that's an interesting thing. Soft, it's a set of questions that you may ask. You need to ask yourself, and depending on your use case, some of the questions will be addressed in one way or the other. Let's start from the financial bit, as we were touching before. On the financial side, what we offer is you pay for the size of the instance, which for us, it's, you are safe to know what you will pay next month. There is no like egress cost to factor in. We take care of it. You pay a fixed amount. Okay. Is that what you want? Or you want, if you want a per API call? Well, this is not what Ivan offers, but still it's in the soft because it's something that you will need to evaluate regarding to your situation. What Ivan does is basically, as I said, we offer an easy and trustable developer experience with data platforms. So, for example, let's say technological scaling. We make it really, really easy. Because with Kafka, you can add or remove nodes. With Postgres, you can add, you can create a bigger instance or a smaller instance. You can create a primary and several read-only replica. You can move between clouds. Let's say that my business now is in Italy, but tomorrow I will move to Australia. Yeah. With one click, I can take my database, which is now sitting in Amazon Milan data center, move it to Google Cloud Sydney. Yeah. Ivan takes care of it. If the primary node of my database has problems, Ivan automatically takes the read-only replica and makes it master. And my application doesn't see anything. If I have a retry option, if there is a network problem, my application will not have a problem because we swap the host name, so the replica will have the same name as the primary. Then about business case scaling, we offer the best of open source, and the project that we offer have the option of all the security option to segment the data, however you want. We are also building tools on top, for example, of Kafka. It's called Claw. It's a new acquisition that we made, and it's an open source tool that allows you to say, to add proper procedures to request a new Kafka topic, a new Kafka connector, and stuff like that. Something that in the pure open source project doesn't exist. We are adding it and making it fully open source. Human scaling, of course, we offer some of the best open source tools available with a huge community. One thing that I wanted to say now is that a lot of what Ivan offers is because Ivan needs the same technology to run Ivan. So we use Kafka for our own usage. We use Postgres for our own usage. We use M3, OpenSearch. We create something, we test within ourselves. When we think it's ready, we offer to our customers. And working on top of open source means that, and on top of such successful open source project, means that the talent is really huge. The talent pool is really huge. And also means that you have the choice. Are you feeling good with OpenSearch with Ivan? Stay with us. If not, well, it's your choice. Like, what I like being a DevRel at Ivan is that I can build all the demos that I want, and they can work locally on a Docker container with the open source version of Kafka. Or if you want to have a better and slicker experience, you can come to Ivan.
Okay.
Then the observability, we enable it because with a couple of clicks in Ivan, you can, for example, take the logs of your Postgres database or your Kafka instance and send it to Ivan for OpenSearch service. Or if you're using Datadog, we send them to Datadog. You can have InfluxDB for metrics. You can use the Ivan one, or you can use whatever service you are already using for other things. We offer to you complete visibility on what's happening. We offer one-click upgrade. You can even automate the upgrade.
Okay.
So, for example, we don't offer the automation as of now, but what you can do is you receive the metrics stream in a specific table of whatever. You check if the average of the CPU is over 80%. Well, you can call our API or with our Terraform provider or with our CLI and start the upgrade. And again, the upgrade is with no downtime. So we start the new service, we add the new nodes, we move the data to the new nodes, and everything stays up and running while you work with the data. Then about recreating the bird's eye view. This is kind of a complex topic because, as we said, data platforms is usually a set of different tools. It's not only one tool.
Yeah.
So there is not out-of-the-box solution for this. What I've been working in the last year was to build a tool which is called Ivan Metadata Parser. Maybe we can share the link later.
Yeah.
It's a tool in Python that uses the Ivan APIs to get information about all the services that you're running with Ivan, and then goes into each of the service and starts querying all the metadata and try to rebuild the bird's eye view by combining the metadata. Let's say that you have a table in Postgres, which is sourced by Kafka via Kafka connector, and then it's transformed by Flink, and then it's pushed to OpenSearch. Well, if you smartly analyze all the metadata of all the services, you can recreate a graph of your data lineage. It's quite a big effort. The project itself, it's still at the beginning, but possibly it's a way to recreate the bird eye view, even if you didn't have it out of the box. Or at least, even if it's not 100% accurate, it gives you an initial information which is way better than knowing nothing about the data sets in your company. Then, history replay and data versioning, we already touched on that. Kafka is the perfect example. Having the storage of the raw events for a long time gives you the ability of replaying them. For fast, it depends what you want with fast. Do you need near real time? There is Kafka and Flink. Do you want a query-based approach? There is Postgres, MySQL. Do you need time series database? We have plenty of them. And then time to develop, time to deliver, time to recover. There's something which, so the performance timing is something that you can check yourself with, depending on the size of the instance, for example, and the type of workload, the type of queries, et cetera, et cetera. Let's say that you have a click stream of data that is stored in Postgres, and you want to analyze the click stream. Maybe Postgres is not the best analytical database in the world. Maybe, again, by using Kafka or by using ClickHouse, which is an analytical database, you can make also those queries faster. And what Ivan does is allows you to build bridges a little bit more easily. But then time to deliver, time to recover. The fact that we expose APIs, we expose Terraform providers, we expose CLI, allows you to build or to include Ivan in your processes. Because we shouldn't force you to use a specific process to, test your next release of the application. You should be able to integrate your, the Ivan part into your existing processes. And time to recover, again, we do backups, we do point-in-time recovery. With Kafka, you have always at least 3 nodes. So and you have always 3 nodes, and the same information is stored at least twice. So you can lose a node, still you're not losing information. And then for Trustworthy, the security bit, it's very important. And again, this goes back to recreating the bird's eye view. This can be implemented in different ways depending on which is the actor and which are the regulations that you need to apply to. But then the ecosystem evaluation, you want to evaluate if a tool that you're choosing now can support you for years. Well, check the Kafka community, the Postgres community, ClickHouse. It's plenty of enthusiast people that want to move the status of the tool forward. Data locality and cloud option. If you don't want to go to the cloud, well, bad luck. We offer all services on the cloud. But if you want to work in the cloud, we work on top of all the major clouds. So you can work with Amazon. You can spend Amazon credits by purchasing Ivan stuff. So we have good partnership with all the major cloud providers. So there are tons of ways that you can use Ivan services, even if you have a tons of credit from Google or Amazon. And the beauty of working on multiple clouds is that I don't have a specific case, but maybe let's say I want my database to be in Rome. Amazon has it in Milan. It's a little bit too far. Does it Azure have it in Rome? Or suddenly tomorrow, I change my purchasing favorite cloud provider, and I move everything off Amazon into Azure. Well, for Ivan, minimal disruption, 1 click, couple of clicks, and you move everything over. And you don't have to basically take care of anything. And the last part is about data correctness. This is a detail of the implementation. We can ensure that we like the Postgres, what you write in Postgres and what you read is exactly the same. But then, depending on like building the one source of truth is much more related to kind of internal politics and the way that the company itself, the other company is managed, not how Ivan is managed. What we do is we do our best. We know that we can rely on trusted open source tools that can say, once you write to Kafka, once you write to Postgres, the data is there.
Yeah, these open source systems are really amazing. I mean, they have vast community. There's a lot of feature development going on, and people trust them. Like people trust Kafka for reliability. People trust Postgres. So yeah, I think that's something with open source we kind of get for free. I mean, because there's this whole community of developers working towards making it better.
The other bit to it is that oftenly what people say against open source is that there is no phone number to call if there is something wrong.
Yeah.
And I believe that is also sweet spot about Ivan. We have deep experts on the technologies that we offer. So you get the benefit of the open source solution together with the benefit of a number to call.
Yeah.
Even more, we have a dedicated team within Ivan called the OSPO team, the open source office, which is dedicated to purely contributing to the upstream open source project. So it's people working purely on the open source Kafka, on the open source Flink, on Postgres. This means that they are expert. They can gather what, for example, what our clients are demanding, and maybe say, there is this feature which I see will come in one release.
Yeah.
Or maybe I can spend a little bit of time working on it. Why not? But it's people dedicated of whatever the outcome of their work is, it's out there in the open. So this adds the little bit of, I use something which doesn't have an official company umbrella, but still Ivan creates this umbrella that allows you to have the support that you need on top of the open source tools.
Awesome. Yeah, sounds really good. If any of our viewers are interested in trying out Ivan, please reach out to Francesco, or look it up on Google. You'll find enough information to get started. And I think today what we have discussed is more like a general pattern of how you should be thinking about building your data platforms. And a lot of this is given to you. You get it for free if you use systems like Ivan. So feel free to check it out. Feel free to reach out to me and Francesco if you have more questions on data platforms. If you think we should do more episodes on related to data platforms, feel free to reach out to us. And thanks Francesco for sharing all the tips based on your experience, based on working at Ivan. And I'm really hopeful that people will look at data platforms from a different perspective, and they'll have a better idea while choosing certain vendors and certain technologies, because as you said, it's for the future. It's not changing too often. So thanks a lot for coming and joining us today.
Thank you for having me. It was a real pleasure talking to you.
Awesome. Thank you.